Sorry I'm late. I was reading a book on anti-gravity and I just couldn't put it down. Put it down. Oh, well. Welcome to Behind the Experiment. I'm Victor Brandalise, and also known as a Mr. B. And this series is a spin-off of those videos that you've seen, Chemistry with Mr. B. And in this series, I hope to show you the process by which I go about doing the experiments, coming up with the experiments for the videos that you see in Chemistry with Mr. B. So, behind the experiment, you'll see that it's not always easy to get a good experiment that works. A good experiment requires reproducible and consistent results to support a hypothesis. So, you'll see in this experiment that I struggle at times, and I do get frustrated, but that's all part of the process. Well, typically how it goes for me, at least, is I have a chemistry question that I want to investigate. So I find a procedure on how the experiment was done. And usually, I don't always have the equipment that they use, so I have to make modifications and changes, which can be fun because I like being creative. And then I do the experiment multiple times to see if I can get consistent, reproducible results. Well, most of the time I don't. And that's when it becomes really fun and challenging, because you have to try to figure out what's the problem, what's wrong here, how to fix it. Well, after numerous times of not having successful results, eventually I do get reproducible results. And that's when it's really satisfying. It's kind of like when you play a video game. You keep playing, and eventually you win, all right? Well, that's kind of what happens with the experiment. So, in this video, I'm going to be showing you the experiment that I did in video 4 of Chemistry with Mr. B, in which I wanted to investigate what happens to the mass of ice when it melts. So my initial experiment went something like this. I got a clean, dry beaker, and I placed the ice cube in it, and I measured the mass of the ice cube on a laboratory balance. This is the laboratory balance that I used. Well, then I let the ice cube melt. I set it aside, let it melt, and then I placed the melted ice and beaker back on the lab balance, and I measured the mass of the ice cube, of the melted ice. Well, then I compared the mass before and after. Well, that experiment, that's how I initially did it. Now, before I get to the results of that experiment, let me just say something about a laboratory balance that I used. This is the lab balance that I used. I purchased it online. It was about $15. It's a very good balance. It measures the mass to the nearest 0.01 grams. That's one hundredth of a gram. It's commonly used in the kitchen, and I've used it in my chemistry classes. But anytime you make a measurement, there's always a degree of uncertainty with that measurement. This balance has an uncertainty of plus 0.01 grams or minus 0.01 grams. Well, give you an example. I massed this quarter. This quarter has a mass of 5.68 grams. That means the mass of this quarter lies between 5.67 grams and 5.69 grams. So if it's 5.68 minus 0.01 is 5.67, plus 0.01 is 5.69. So keep that in mind as you look at my results of the experiments that I did. So back to the initial experiment. Well, here's what I did. I let it melt. Well, here's the results. Now, first of all, the results aren't bad. I got a change in mass. Let's talk about change in mass. Change in mass I use by a triangle, which means delta mass. And how you calculate the change in mass is you take the mass after minus the mass before. Well, I got a change in mass of negative 0.01 0.02 grams, negative 0.02 grams, and negative 0.02 grams. Very consistent results, all the same. Negative means that mass was lost in the process. The trouble was that this took 2 hours for it to melt. All right. Now, I enjoy watching ice melt. And sometimes I have to admit, on Saturday nights when I got nothing to do, I sit down and watch an ice cube melt. It takes a couple hours, and it's actually kind of fun. But to do a video, it's not very practical to have it melt. Take 2 hours to melt. Plus, I wanted to do at least 15 trials so that I could get enough evidence to support a particular hypothesis. All right? The particular hypothesis in this case that I could be investigating would be that there's, first of all, one hypothesis could be that mass increases when ice melts. Another hypothesis could be that the mass decreases when ice melts. And a third could be that there was no change in mass when the ice melts. Well, my particular hypothesis was that the mass was not going to change when ice melts. Ice is just water, and it's in the solid state, and it's just going from solid to liquid, and the amount of matter, the number of water molecules, is not going to increase or decrease when it melts. So that was my hypothesis. So these are pretty small numbers, but again, as I said, it wasn't very practical for what I wanted to do in the video. So I decided, okay, let's use a hot plate because it will melt the ice much faster. Well, I had a hot plate that had a setting up to 5 being the highest temperature. So I set the hot plate at about 3, which I thought was pretty hot. And the change of mass that I got was negative 0.10 grams, negative 0.09 grams, and negative 0.00 grams. The results weren't very consistent, and it only took the ice 4 minutes to melt, which is pretty quick. So I thought, okay, well, let's lower the temperature a little bit on that hot plate. Let's go to 2, set it at 2. It took a little bit longer, 6 or 7 minutes to melt. And I got these changes in mass. Negative 0.03 grams, negative 0.06 grams, negative 0.06 grams, negative 0.8 grams. I mean, my results are not very consistent. And in each case, I'm losing mass. So I began to think, well, maybe the hot plate is too hot. Maybe some of the heat from the hot plate is causing some of the water to evaporate. That's why the mass is going down. So I decided, let's do it. Next time I do it, let's lower the temperature of the hot plate. So here's what I did. I set the hot plate at 1. Remember, the settings go up to 5. All right, well, it took about 32 minutes now for the ice cube to melt. And I got these changed. I got 0.00 grams, negative 0.4 grams, negative 0.05 grams. Well, they're not consistent, and 32 minutes is kind of a long time again for the video. So I thought, okay, all right, well, I was at 1. Let's split the difference. Let's go halfway between 1 and 2. All right. So it took about 13 minutes, 14 minutes or so to melt. But I got these changes in mass. Negative 0.02 grams, negative 0.04 grams, negative 0.10 grams, negative 0.18 grams, plus 0.03 grams, plus 0.01 grams. I mean, at this point, I am totally frustrated because my results are inconsistent, they're all over the place, and they don't support any particular hypothesis. I can't make any sense of it. So I'm thinking about, well, okay, in all cases, the mass is decreasing by different amounts. And I had made the assumption that, I'm just going to have an ice cube melt, and it's cold, the water's cold, the ice is cold, not much water evaporates when it's cold, and so I thought, well, in the time that it takes for it to melt, those few minutes, I don't think enough water is going to evaporate that I'll see a difference. Well, the data was obviously showing me the results were obviously showing me that I was losing mass. So I decided to do this. I took my beaker and I placed a saran wrap on top and I sealed it. Now I created a closed system. Nothing could get in the beaker and nothing could get out. Whereas before I had an open system. And if water was going to evaporate. It could evaporate. It could leave the beaker. So, now with my closed system, these are my results. Look at this. All right, I did a total of 18 trials. One up here, 9, 4, that's, let's see, 10, 14, and 3, and then one more trial, 18 trials. Out of the 18 trials, 9 trials, I got a change in mass of 0.00 grams. Remember, now this lab balance has a level of uncertainty of plus 0.01 grams and minus 0.1 gram. Well, I had one trial of minus 0.01 grams, and I had 4 trials of plus 0.01 grams. That means 14 out of the 18 trials, the mass lies between negative 0.1 grams and positive 0.1 grams. 14 out of 18, that's 78%. And so I think I had very convincing evidence what the mass was, that it was 0.00 grams. I had a few ones over here, plus 0.02, and plus 0.1. But, or excuse me, yeah, plus 0.2 and plus 0.303. Now remember, it depends on the device and also the ability of the person measuring the device. And so I just, I was measuring it, and so to use a scientific term, I probably goofed up on these, all right, these 3 or 4. All right, well, at any rate, I think with this experiment now, I have convincing evidence, and I can conclude that for a closed system, when ice melts, there is no change in mass when it melts and becomes a liquid. Well, took me quite a bit to get there. I thought it was going to be simple at the beginning. But, as I look back on it, I'm kind of like, well, duh. I mean, if you have an open system, of course, and you're measuring mass to 0.01 grams, 1/100th of a gram, you're probably going to see some difference. And so I'm like, well, I knew that in doing this experiment that I had to make sure that any change in mass that I saw was because of the ice melting. So I couldn't have things leaving the beaker or things going into the beaker or out of the beaker. That I had to control that. I had to have a closed system. Otherwise, I wouldn't know what was causing the change in mass. So with a closed system, I know that if there was a change in mass, it was what was happening with the ice. It was going from solid to liquid. So I'm kind of like embarrassed, like, why didn't I do that from the very beginning? And I got to confess to you, it's like my initial thought was I just wanted to do the experiment, keep it as simple as possible, just put the ice cube in there. And I really thought, I made the assumption that I wouldn't be able to see a difference even if a little bit of water evaporated. Oh, well, live and learn, right? I mean, I'm only human. I make mistakes. And when we do experiments, we're humans doing the experiments. And we're going to make mistakes. But if you stick with it and you do it enough, eventually you learn from your mistakes, you learn from your failures, and you even learn from your successes. So, for all you young students out there in a chemistry class, and you get frustrated when your chemistry lab experiment doesn't work, keep this in mind. You usually only get one chance to do the experiment in class. So, what are the odds it's going to work out for you? I mean, the first time you baked a cake, did it come out the way it was supposed to? The first time you shot a basketball, did you make a basket? Or the first time you played a video game, did you win? Or the second time you played, or the third time, did you win? It takes multiple times, multiple attempts. And each time you learn a little bit more about what you were doing wrong. So, for you like chemistry students, you just need more chances to do the experiment, and eventually it will work for you. So don't get discouraged. All right? Continue to investigate by doing experiments. All right? Do experiments on things that, when you hear things or read things that don't make sense to you, do experiments, investigate, discover the answer for yourself. You're going to be happy and satisfied with yourself that you discovered the answer on your own. In addition, you're going to be developing problem-solving skills and investigative skills that will help you so that maybe one day you'll discover something that no one's discovered. So you're going to feel, just like in a video game, you're going to feel a sense of pride and satisfaction when your experiment finally works for you. Oh, there's the bell. Well, this has been Behind the Experiment. And I'm Mr. B saying, be more than curious. Investigate by doing experiments. Good luck, and break a beaker. What? Why are you still there? You're still there. What do you want? Huh? What? Oh, I see. You want another joke, okay? Yeah, okay, all right. Here we go. Why do chemists love and are so happy in the lab doing experiments? Huh? Why are chemists so happy in the lab doing experiments? Because they're in their own element. Because they're in their own element. All right, well, you have a great day. Because they're in their own element. Oh, Brandalise, you're killing me. Oh, jeez Louise.